Hi everyone, welcome to the stream. And today we will continue our work on the iCEBreaker or the iCEBreaker bitsy board. We did in the last episode, which was a few days ago, we did some work on the iCEBreaker, and we have this to-do list that we would like to complete today, if possible. I also added one additional to-do item so that I don't forget. We need to add some 3D models. I actually realized that the 3D model that should be on the button that we changed is actually still there. I just have to link it properly. Anyways, so last time we updated the button itself to use the same one as on the full-size iCEBreaker. We corrected the CDON indicator LED to be blue, replaced normally open jumpers to normally closed jumpers to simplify the layout and make the signals actually separate. So the problem with using just one net for the signal results in an issue where it is really hard to validate if you disconnected the jumper correctly. So what can happen is that you connect the input signal to the same pad as the output signal, and you will not be able to see that you made a mistake there. So using jumpers that are normally closed, so have this workaround thing that I showed also on the last stream, where there is a trace on the graphics layer that connects two pads, but it's not picked up by the DRC and doesn't connect the nets logically inside KiCad, but it is a way of managing that issue and having two separate nets around the jumper. So that's what we did last time. Then we decided to remove the SRAM flash programming swapping jumpers. This is something that we don't really need in this case, as we discussed, because we are using an external programmer anyways to connect to the iCEBreaker. So what I made for myself, so this is another project. So this is an FTDI chip on a board, and it breaks out all the pins of one of the channels. And then I made a big pile of different adapters. This is not productized at the moment yet, but the designs are somewhere online. It should be on my GitHub somewhere. And I made multiple adapter boards that connect this. So we have an adapter board to program the iCEBreaker, where you basically just connect it like this and you can program it. This shouldn't be necessary for most situations because we will have the bootloader on the FPGA. And so the main thing we will need to do is for an adapter like this to have the MISO and MOSI swappable. And with that, we don't need to swap those signals on the iCEBreaker, and we can just connect the wires differently. And why would we do that? One configuration, the default configuration, is to load the bit stream into the flash chip, and there is a way where you can make the FPGA being a slave to this, or be the client or the target of the data that you're sending. So you're configuring the SRAM inside the FPGA directly, instead of flashing the flash chip, then restarting the FPGA then loads the bit stream out of the flash. Loading it directly into SRAM is usually faster, and it doesn't wear out your flash. And there are certain situations, the flashes have huge amount of cycles. So normally, again, you don't care. But if you are doing some, let's say, genetic algorithms that generate different bit streams, or are trying a huge amount of bit streams, then it might be a good idea to load the bitstream directly into the FPGA and not use the flash chip at all, or just keep some additional payload in the flash chip. So yeah, if you swap the pins and disconnect the chip select from the programming connector, then you will be able to the flash chip, then the flash chip will not get triggered and you can load the bitstream directly into the RAM. So we removed those jumpers. We also added an RGB LED with jumpers. This was something that we do have we have this footprint for an RGB LED on the big iCEBreaker. We don't have jumpers on here, but I decided it would be nice that the bitsy has an RGB LED and you can optionally disconnect it if you want to use the signals for something else. So that's why we added the jumpers. Then we have, now for today, let me, JK, thank you for following. So for today, we have a few more to-dos. The first one is add a Ps Rom footprint. So as I explained last time, you can piggyback a Ps Rom chip on the flash chip on the big iCEBreaker and use this extra pad that is on the side here to connect the chip select of that Ps Rom chip, so you can hack a Ps Rom additional memory or RAM to the big iCEBreaker. And it would be nice to have something even better on the bitsy. So because we got rid of the jumpers on the back, we should have hopefully enough space on the back of the board to put a full footprint for the Ps Rom. So as a user, you can solder on a Ps Rom chip on the back of the board and and play with that. Then the MEMS oscillator, this is an interesting thing. So for some reason, again, as I explained last time, I used an SOT235 chip or the package for the oscillator. It's not super common. It is available, but I guess DigiKey had that at that time at the lowest price point, and that's why I chose it. And I saw several of them, so I thought it was fine. But it turns out they're not as easy to get as other packages, so we will be changing that. Yeah. Then there is the VPP 2.5 volt circuit, so we will get rid of that. This is really only necessary if you want to write the one-time programmable memory on the FPGA. This doesn't happen very often on development boards, so we will oh, thank you, Mike. I see people in the background are already fixing each other's bugs. That's nice. Thank you, Mike, for taking care of Drew's problem. Yeah, so the 2.5 volts, what I will do is, instead of having a circuit that is currently questionable if it works, it might work, but yeah, it's not very good, not great type of circuit. We will just get rid of the additional part that it entails, replace it with a jumper. You can still then supply 2.5 volts if you want to use the one-time programmable memory, and that should be fine. And then we should add the button 3D model. I assume we will come up with some other to-dos as we go further. A side note regarding the stream setup, I will try to move this so that it is better visible. So yeah, on question from GoJimmyPie, he asked me to add something so he can see which buttons I'm pressing when I'm using KiCad. That's why I added this preview, so that now if you press Control or Alt, you will see which buttons I'm pressing when I'm operating KiCad. I hope that will be useful. I didn't realize that it was overlapping with the chat when I was placing it, so we might need to tweak it a little bit. Jordi, how do you feel about using manufacturer-supplied step models versus building from scratch in FreeCAD? Well, I use vendor-supplied step files in some of my boards. you essentially cannot distribute those models in most cases because of how the licensing works. I think there are several reasons. One is like IP type of reasons. The other one is vendors rarely actually put a proper license on them. And thirdly, they want you to always download from their website so that they stay up to date. So building from scratch in FreeCAD is the only properly legal way for us to distribute and share the 3D models with each other. So if you see 3D models in KiCad, the ones that are built into KiCad, they are usually built from scratch or using scripts. So I actually did generate 3D models for the footprints that I submitted to KiCad a few weeks ago. And the scripts are there. They are usable. Still, all the exceptions apply where I wish the situation with the scripts was a little bit more clear and easier to use. But at least I don't have to build all the models by hand in FreeCAD, which is nice. But yeah, I usually am not patient enough to build the models myself because it is quite time consuming. So just to get the view and the feel for the board and make a rendering for Twitter, I download the step models from manufacturers. I don't usually even color them. I should at least do that, I guess. But yeah, at least KiCad now supports step files, which is nice. Oh, nice. Drew's examples for Nmeigen work. That's very cool. Awesome. Okie dokes. So let's get going on this. So the Ps Rom footprint on the back of the board. So let's add this to the circuit. Let me check one thing before I get going. I think the additional chip select is connected to the green LED I/O that is used for the Ps Rom. I have to check that because Sylvain was questioning that yesterday, and I am not sure who is right and who is wrong. So let me just check it in the original file. Open recent. So this one. And schematic. So we should have an additional pad. Where did I put this though? That's the question. Yeah, so it is LEDG. So it is the green LED I/O signal that is being used for this pad. Yeah, I see where I put the pad. I put it here. This pad actually should be near the flash chip, I think. That would be more logical. Yes, so yeah, that's exactly the situation. Yeah, so two things, Jordy. Yeah, that's how I use it. I still, in my own library, the PK libs, I have the vendor models in there. Don't care that much there. If I was submitting it to KiCad, I obviously would have to either remove them or generate my own models. So that's the situation there. Yeah, so I just wanted to make sure, Sylvain, that's all. So that we don't make a stupid mistake here. And escape file, open recent, bitsy. Actually, I want the schematic. All right, so I also looked up which part we should use as a reference. So this is a Ps Rom chip that I found on LCSC. It seems like a decent solution. It's 64 megabit, so it is 8 megabytes of RAM. This is, I think, the biggest QPI part that I could find on LCSC. And this is in a 150 mil SO8 package. I don't know what the default is. I never remember that. But I have the datasheet here. We can compare it, and then we should also make sure that the pinout is correct. And I should finally remove my phone from my pocket because it keeps vibrating in there. Ah. Drew is asking on Twitter what camera I'm using for overhead. This is a Lumix G7 that I'm using, that I got at a very good deal from our good friend Chris Gammel. What is shipping like from LCSC? At the moment, it seems like half a week to a week delay from normal shipping times that we had before that. They still ship the same day as they used to, if they have it in stock. So they seem to be fully operational. The shipping itself, and I'm only talking about DHL and FedEx. I currently have a DHL package on the way, and it seems, so it was scheduled to arrive here on, I think, Wednesday last week, and now it is scheduled to arrive on Monday. So it is half a week delay. And the FedEx one didn't ship yet, so I don't know what the shipping time will be there. So we will see how I think the main delays currently are from the shipping, express shipping services. And I will keep you up to date when I know when things arrive. Okay, so this part, we have to make oh, that's interesting. We have to be careful with these parts that we use the 3.3 volt version and not the 2.0 volt version. Haha. So it's essentially a 1.8 part, these two, and this is, it's MSME. Ah, yeah. So this is the the normal E temperature range. Okay. Pinout should be, I don't even know what this footprint, what is this symbol from? PKL memory. Oh, so I created my own pinout for this. So the question now is, do we need to make a new symbol for this? Chip enable, chip select is 1, 2 is SO, SIO, 2. 1 seems to be the same pinout essentially. So I could reuse this as a symbol, I think, even though the naming is not the same. You know what? I will make a copy of this. This is a safer solution. Let's not be lazy here. So let's load the libraries and make a copy of the memory symbol. Duplicate, and we can rename this. Oh. How edit? Will this change? This is just the value. Symbol name. Ah, there we go. I should probably also use a proper name for this part here. VTI 764, that's I think the common part of here. Yeah, let's just use this. So the music in the background is Spotify. There's a playlist, and it is linked in Twitch under the video. There's a link to that playlist that I use. Okay. Did it rename? Oh yeah, perfect. Okay, cool. So that's that. Then we can rename the signals to match what the datasheet says. CE. Pin 6 is S clock. It's not a big difference there. Oh, come on. 5 is DI. SI, SIO 0. I'm not sure I should be doing this. This feels pretty silly, to be honest. 5, then 2 is DO. SO, SIO. We already started down that path. Let's finish it. Oh, come on. Having 2 monitors for working on KiCad is pretty much mandatory. Liontech one. Huh. So this there is a bunch of parts on LCSC that you will not find at other distributors because they are Asian market specific, and so LCSC is the place to get them. The reason why they are usually, if you get the Chinese brand parts, they are very often, so LCSC is actually putting a lot of effort into making sure that they are genuine parts, and there you have some safety there, so you can return parts. They have a vested interest that these are not fake parts or anything. So I feel a little bit more confident buying stuff from LCSC than buying on AliExpress, obviously. Especially you have an inventory and you have a list of things and you can ask for quotes. So it feels more like a normal distributor. But they also have those Chinese or Korean or Taiwanese parts that are not available on the Western market, and they are usually very good, well priced, because they are more for the mass market production, and they are deeper into the layers of the manufacturing quantities. And yeah, so there's many parts or many vendors that I had no idea even existed until I started searching for stuff on LCSC. Okay, so SO, what is the next one? Number 3 is SIO2. Doesn't have write protect, does it? Oh, come on. Huh, interesting. Oh yeah, well, there's no write protect because it's not a flash chip. Yes, so yeah, it's like, is it 5x cheaper? Is the Liontech 5 times cheaper or this one? Okay. Sorry, I'm trying to catch up on text here. Oh, the Liontech. So for the Liontech is cheaper. Oh, interesting. Okay, well we will have to check that. I probably will have to also, if we are making those iCEBitsys, we should probably stock some of those RAM chips for people to get as part of their order, so that they can solder them on if they want to. Yeah, I will definitely check. This was the biggest part and the only biggest part I could find on LCSC. So yeah, it's the 64 megabit serial SRAM chip. Oh, thank you, Jordi, for explaining. Yeah, welcome to the stream. Crash test zombie? Awesome. Yeah, so essentially we are working on FPGA boards, and these are not Arduinos. These are FPGA development boards. They have the same form factor as some pretty common Arduino boards, like the Teensy. That's an actual Teensy. And this is the Adafruit iCEBreaker. So yeah, or the 1-bit squared 1-bitsy. So they are all in the same form factor because breadboard compatibility. What normal supplier would you use for a part like that? You mean a part like the one that I'm looking at here, the Wilson technology? I would buy them from LCSC. That's I wouldn't use DigiKey or Mauser for them. I buy a lot of parts for production actually from LCSC. For example, resistors and capacitors. They are 1/10 of the price of quantity pricing from DigiKey, Mauser. They seriously, like, buying a reel of parts on LCSC is $2.50, and buying a reel on at Mauser, also a full reel of resistors, is $24. So yeah, no. Customs. So if your order is, we're getting into very interesting territory of sourcing parts here. If your order is under $800, you don't pay neither the tariffs or customs, at least here in the US. So under $800, you're fine. Anything beyond that, you start paying the fees, and it's hard for me to, I don't remember, because this fluctuates so rapidly at the moment, thanks to the government we have, and so it is more expensive, but it's still way cheaper, even including tariffs and taxes. On top of that, than buying from local distributors. But yeah, if you are a small company like we are, you do try to order in smaller batches, essentially. So yeah, then you can save some more money on this. Yeah, you're welcome. Okay, so let's get back to this. These are good tangents, though. This is I find this stuff interesting, but yeah, yesterday, for example, I spent the whole day consolidating quotes for the Glasgow, and just spreadsheets the whole day. It's but even though it's tedious and annoying at first, when you see the prices like start aligning together and you are seeing where you can save some money by ordering from different distributors, it's actually exciting to see, oh, I can save some more money and I can make a little bit cheaper and more affordable product because of this. So I find it fascinating, and it is actually a lot of fun, but it's incredibly time consuming. This is something a lot of people are majorly underestimating when you see people manufacturing stuff. The just stupendous amount of time you're spending sending emails, asking for quotes, negotiating with vendors, trying to convince them that you are their best friend and they should give you a better price. It's such a time sink and so time consuming. So when you see, especially from a smaller manufacturer, something at an affordable price being sold, either they are not making any money, which will result in them sooner or later not making new things anymore, because they cannot sustain themselves, or they spend a huge amount of time on making it more affordable for you. So it is not like, it is easier if you are in Shenzhen in certain ways, where you just, it is easier to go to a vendor, put a list of things, here, make this thing, and just they start cranking it out. But there's a lot of development time and a lot of optimization time you put in, especially if you are not living in China, in Shenzhen. Yeah, after you spend a bunch of time finding the correct part and digging through all the options. Yeah. I know the feeling. But yeah, so let's get back to the KiCad part. So where were we? We are 3. We corrected that. 7. What is the name? SIO3. SIO3. Okay. And then VCC, we can just leave it as VCC, I think. Yep. And for, they call it VDD and VSS here. That's fine. Let's leave it as is to make it a little bit less confusing on the schematic. Now we can add it to here. So flash and RAM. Let's see if we can make some more space here. That will be fun. This is pretty dense already here. Maybe let's grab this guy. I want to stay on the double grid. Okay, let's see if that fits first. PKL memory. Then we have the VI. Yeah, I might rename that symbol eventually, but what is happening here? Okay. Alrighty, so we can move field. Yeah, we can just move them here to make a little bit more space. Field reference. So let's do that here. Like this, and then we can put this guy like this. Oh, that was mirrored. Okay. There we go. That should be better. And then, oh, I'm annoyed. I need more space. This is a little bit too dense for my taste. We could just put them on the right side and then connect them down. Yeah, I think that's how we do it, at least on the right side here. Like this. that should be good. There we go. And these are not actually exactly right. So this is correct. This is SIO. One. Oh, we started on this side. Let's do, yeah, let's do this way. That's fine. Like this, and then like this. And then this one is, I think, oh, tab. There we go. Chip enable, I think. The pull-ups were, we just need them on write protect. This is irrelevant because they are connected in parallel anyways. Chip select should be pulled up high. I think this is correct. Should probably have memorized what the connection was before, but I hope that I got it right. Like this and like this. I hope that's correct. We will need to verify this later. We don't need a second decoupling capacitor. Nope. Oh, it won't be connected together. Right, you are correct. You are correct. So, how do we do this the stupidest way? Something like that, and then give it a new name. Oh, this is the green LED. Yeah. That's connected to. Where is it? Where is it? What is the signal name? LED G. There we go. So that will be the LED G. Yep, perfect. We actually don't need to do that. We can do like this and then move. Yeah, there we go. That should do it. We still need more space here. So let's move space here. Because we need more. Thank you for follow. Twistes. What? Twisted Sitzer? Twisted Sitzer? Is that what the name is? That's a good name. Really good tongue twister, I guess. Yeah. Oh, welcome. Thank you for coming from the Scanline Gitter. I'm trying my best. I will try to read your name a few more times. Maybe I will get the the pronunciation right. Yeah, thank you for your follow. Okay, so we can expand this here. No. Like this. And then tab. So we need to do 1, 2 additional signals so that this is pulled up here, this is pulled up here, then we can connect these guys like this, and then like this. That looks good. There we go. And now we need to connect the 3.3 volts, which is annoyingly, we don't have much space here. Ugh, so annoying. Oh, I can move it. I can make more space here. Right. There we go. Let's make 4, yeah. And then we can move this. Something like that. And then there we go. That looks cleaner. Oh, come on. Like this. And then like this. Yeah, I think that's clean enough. And then we should move this naming properly, right? Like that. Ah, this has to be moved anyways. What? Yeah, let's move this. There we go. That's definitely better. Now the question is, I have to choose a footprint for this. And we need to check that the footprint is the correct one, because Soik. So this is the 5.3. I think I can use it just from the standard library. Come on. Pin header, pin socket, these are connectors. Package, connector, package, there we go. SO, MSOP SO8, 1, oh, not EP, because that's exposed pad, we don't need that. And then I need to see which one of these this is. What I think the 3 millimeters 4.9, that's the body width, the 4.9. I never remember. Oh, come on, where's the data sheet? Okay, let's scroll down in this and see for look at the mechanical drawing. So E1 is the body width. E1 3.8 to 4, so it is 3.9, 3.9, 3.9, 3.9 by 4.9. I should open the editor, I think, to make sure. Let's open the editor just to make sure. Hey, welcome, Jimmy. Welcome to the stream. LED G, what is the highest voltage the LED G will be? High enough? Well, it is connected to 3.3 volts, so it will be fine as a chip select here. And we are connecting it on the GPIO side. It should be fine. It should also get the high and low. It's going from 3.3 volts down to, yes. Yeah, when there's no current flowing, there's no drop. Well, when it is high, it will be 3.3 volts. But when it is low, then yeah, there's current coming. I don't think this will be very much above 0 volts. I think it is negligible at the end, because we are on the not on the resistor side. If you look here, the LED G, where is it? There. LED G, the resistor is there, the diode is there, and this is the signal that we are connecting also to the chip select. So when it is high, there's no current flowing, so it will be high. And when it is low, we have like we don't have much current going through here. It should be totally fine. But yeah, we will test it for sure. Yeah, 0 when pulled by the IO. Okay, yeah, sure. when there is no current drawing. I know what you're talking about now. When the LED itself is being used as a pull-up, then yes, it should also be 3.3 volts, because there's not really much current going through it, because the chip select pin will be high impedance, like pretty high impedance. Okay, so let's go to the package SO. SO8. What are the SO8s that we have here? SOIC. There's also SOIC 8. What? There's SO8, SO8 5, and then there is SOIC 8. Okay, there's a little bit of a naming mess going on in the library. Interesting. Or maybe I generated that. That is totally possible, because it might be my library at the moment that I have locally. So I was contributing a bunch of footprints, and I might have created a little bit of a mess here. I'm pretty sure these are the upstream ones. So yeah, anyways, so let's check the width, which value corresponds to what, because I don't remember. So the width of the package is 3.9. So the first value is the width of the package, and vertically it is 4.9, so that's the second value. Okay, so we need 3.9, 4.9. That should be correct here. Come on. Too many browser windows. 3.295 volts. So yeah, thank you so much. It will be fine. We are good. Okay, so D is 4.75, 5.5, so it is 4.9. 5, this is 8, 9, yeah, 4.9. Okay, good. That's the midpoint. Cool. So this is our footprint, the 3949. Okay. And now let's do F8. Hello. There we go. Annotate. Update PCB. Close. Now we have the footprint. Now we can flip it. So now the fun part is that these are crossed over completely. So we will need to do some railroad track fixing here, because they will not be aligning because they are mirrored. It would be nicer if they were both on the same side of the board, because then we can probably make something easier. But yeah, that is what it is for now. And that should be the center. So let's place this guy here, and we will worry about it later. Pitch down. Yeah, we have traces here that we will have to avoid. Let's move this guy again still. Yeah. Did this selector... So I thought last night, because the nightly stable, I submitted the bug with the selection about selections of footprints. So that was working just before the stream. So that I could select this chip. So I submitted it as a bug report to KiCad, and all the developers are saying it's like, this is fixed. There is no issue here. I cannot reproduce it. But as soon as now I'm streaming and I started doing a few things, it's again, I cannot select things, and the system that should be popping up this menu for disambiguation is not popping up when I try to click on here, where it should be complaining, oh, you have the big SO8 and the small SO8 on two sides, and you should be able to select them. So that worked just before the stream, and now it's not working anymore. So there's something is being confused by me manipulating the board, is being confused in the disambiguation heuristic thing. But I was told also as part of the pull request or the issue that if you press Alt and click, you will force this disambiguation menu to pop up. So for now, we can just do this, and I will still put it to the side because I need to push these traces out of the way before I plant it in there. But yeah, we can say now that this to do is also checked off. Then let's look. I think these are easier. This one and this one is easier, and we do the MEMS oscillator as last. So yeah, let's do these first. Wrong. There we go. So let's do the VPP circuit modification first. Okay, I need to catch up, I think, on the stream. Flipped vertically. Having it upside down might help, so they're aligned horizontally and flipped vertically. And then you can use top layer for one side and bottom layer for the other. I'm not exactly sure I know what you're saying. Yeah, I will play with this when we get to the routing part and we finish with the schematic modifications and adding parts. Yeah, I guess you mean rotating it like this, and then having something like that. Yeah, then we can just cross it over like this. Yeah, yeah, have it on one side. Yeah, that's probably not a bad idea. Yeah. Then we can just go in, and then on the top side go to the bottom, and on the bottom side go up. So sorry, I'm pointing with my finger. This is not, you don't see that. So we go with the traces in, and for the bottom side we go up, and for the top side we go down, and this way we can get this routing right. Yeah, that's a good idea. Thanks, Sylvain. That's a good solution. Okay, replace VPP with the jumper. So let's do that. So all we need to do is, I don't think we need this guy. This guy, or this guy, or this guy. We can leave this footprint as DNP in here, just in case someone wants to populate it. And we can replace this one with a normally connected jumper. Up, wait, copy, there we go. If you're wondering why we are doing this, I explained it earlier in the stream, and I explained it or Thursday in the previous stream quite accurately why we did that. And we did also an additional chat with someone who has first-hand information about Lattice products, and he also confirmed that we understood it probably right. This capacitor actually on this side, which is missing on the official Lattice dev boards, might improve the situation to a point where this works and you can actually do NVCM. But this is not really common on dev boards that you would do that, so I think it is safe to just put a jumper here, and if someone really wants to do that, they can separate it and use it. So that's my take on this. Alrighty, so that should do it. Let's update this. We have this jumper that is replacing, oh, it didn't remove, yeah. Escape, let's undo this. Oh, it did remove it. Okay, wait. Yeah, it did remove the footprints. Okay, cool. And we can just put it also on the flip side, because there's no need to have this on the front. So let me just drop it in here, and we should rotate this. Something like that. Page up. Yes, it still connects to 3.3 volts. So you can power this from 3.3 volts. You don't need to have the 2.5 volts there unless you want to program the non-volatile memory inside the FPGA, which is one-time programmable. Yeah, I will need to do some more cleaning here regarding those traces. Oh my goodness, this will be fun. It will be quite a puzzle again. But this is what we are here for. Yeah, let me move it a little bit out of the way here. Yeah, I have to figure out what the routing in here will be, because this is becoming a little bit more intense. And I still have to connect the flash and the RAM chip in here. And the programming pins have to be connected again. So there will be a little bit of fun for all of us. Non-volatile configuration memory, yes, NVCM. You don't usually use it. So NVCM is not used in normal operation of this FPGA. It is only if you don't want to use external flash and you want to load the bit stream permanently into the FPGA and use it as a static chip, essentially, that has one configuration and that's it. If you want to save on an additional part and you want it to start up a bit faster, I think it starts up slightly faster. you can use the NVCM. But for a dev board like this, it's good to have as an option to try out if you are developing, but this is not something you normally would use. Yes. Okay, so I think we have that done. Now let's do the 3D model for the button. So that will be Alt 3. Let's see. So this is the current 3D model we have. As you see, I replaced logos with something. There's a very good reason why there are placeholders for the logo in there. All right, so this is the 3D model, and currently we are missing the LED 3D models and the button 3D model. Let's fix the user button 3D model first. That should be pretty easy because the model is here. Let me see on the command line. So I have the model in the PKL library. Packages 3D, PKL, button, switches, and then we have the PTS step model. And then we can add this. And the important thing is this variable, $. Come on, what's going on here? Ah, shift, there we go. Kai project mod or something? Kai project? I never remember the variable name. Preferences, manage footprint libraries. Kai project mod. There we go, so that it is relative to our path. Okay, and there we go. The 3D model is actually already there, if you see here. It is not aligned correctly, so we will rotate it around. So rotation around x-axis is 90. I think it is actually minus 90. Minus 90. Oh, come on. So we can remove this guy because this doesn't even exist. Thank you for the follow. Slothazar Rex. That's a good name. I can pronounce that. Thank you for the follow. Okay, so this is the footprint. Let's do minus 90 on X. Minus 90. There we go. And now we also need to pull it out of the PCB because it's sticking in there a little bit too much. I might be a little bit of an assembly challenge to do this. Well, we can grind it down like TubeTime does to all his parts, as far as I understand. If you have not what I'm referring to, TubeTime on Twitter, he is taking sandpaper and cutting different electronic components in half and making really beautiful photos of this to show the internal construction of them. You seriously should check it out on his Twitter. TubeTime US, I think, is his Twitter handle. Okay, and offset in Z. Embedded components, yeah. Yeah, we should just mill a pocket in there and then add solder underneath so that it is recessed into the PCB. That would be fun, actually. Yeah, or make a PCB that has the button embedded inside. So you would have a pocket on the inside that is the mechanism. So if you squeeze the PCB together, you make contact or no contact with an internal surface. That would be interesting. Yeah, I think it actually came up. The reason why you would need that is for flat flex designs and any different other weird stack-ups where you have areas that have pads on internal layers because of flat flex, or you have rigid of different layer counts. So you have a 2-layer PCB, and then you have additional layers on top of that, and then you have a flat flex. So you can have pads on internal layers, even though it is actually exposed. So it's not that crazy to request having that functionality, and it did come up somewhere on the KiCad mailing list to actually add that functionality. So I'm pretty sure it will come sooner or later. Yeah, so let's see. 1, and I think this was 2, 3. Let's do 5, because we want usually the parts to hover just a smidge above the PCB. So 0.1 should be fine. So that should be okay. Now let's look at the 3D rendering, if we can. There we go. And there we go. Yeah, as I said, I didn't paint it. I didn't put the effort into painting the button, but at least we know mechanically where things are. And I should reflow the pour. Yeah, the pour is refilled. Okay, so that's the button. Now let's fix the LEDs, because I'm pretty sure there's a model for that. Let's 3D shapes. Oh, no. Trash it, look in the library. Packages 3D. 0603. Oh, there's castellated version. Oh, that's cool. They now have this is new. The castellated version didn't exist only recently. So which one do we use? Let's use the castellated one. Castellated. Oh, wait. I also want to copy this. And I can delete this because that doesn't exist. And then can just do this, and now that should be updated. There we go. So now we have, oh my goodness, these are tall. What is going on with those LEDs? They look really tall. I don't think they are that tall. These lenses are huge. Yeah. Yeah, those are quite big nipples on that board. Okay. I'm sorry, I had to say it. Is there a Z factor on them? Maybe there is a Z factor on them. No, they are 1. Well, I could decrease the Z factor. Yeah, that looks much more reasonable. Okay. Yeah, let's decrease the nipple factor on this. That's this board, and then, come on. Dude, open the other footprint, please. Thank you. There we go. That looks much more normal somehow. Yeah. Okay. Cool. Let's save this. And we have another to-do item to cross off. Oh, well said. Thank you. Sparrow Division. See done. Yeah, see done is missing. And I don't think we have anything else that is missing at the moment. Cool, cool, cool. So let's just copy it from here. I wish there was, actually what would be really cool if KiCad had parameters to step models so that you could say which color the LED is and it would automatically change the color of the lens in the step model. If there was like some anchor inside the step file that you could pull in parameters that you pass on from this dialog, that would be so cool. I'm not sure it is possible, but that definitely would be cool. I will check the passives in a minute. Okay. Come on, come on, come on. There we go. So that's there. And the only thing missing is this RGB LED here. And I'm not sure there is a 3D model for that. So let's see. Let's browse the 3D models in KiCad a little bit. These are not passives, this is an RGB LED. Senior Sigma, thank you for following. Welcome to the stream. Okay, so let's see. Metric. Huh. It's just huge block. What is going on with the scaling factor on all of them? I have the feeling they all are... Oh wait, this one is the right size. The 0402 is massive. 0603. You know what? I have a bad feeling about this. I have the feeling that this is my local library being wonky because I was messing. I might have generated those 3D models by accident. Yeah, I will have to check that after the stream. But yeah, for now, let's leave it and see if we can... Innolux PLCC. Oh, there are the PLCC parts. That's nice. RGB 5050. These are very common. SK. WS2812s, of course, because that's important. And the Bs. Yeah, I don't think we have square RGB LED 3D model at the moment, so we will leave that out for now because I don't feel like firing up, or maybe I can download one from DigiKey or something. Let's see if we can find DigiKey 3D model. This is PTS. And then let's see, RGB LED. DigiKey usually by now has also 3D models in there, so maybe we get lucky here. Cthurlo, thank you for a follow. Welcome to the stream. Indicators, arrays, light bars. No, that's not what I want. Do I? Indicators? No, that's not what I want. Osmocom. UHD. Oh, is that the one from the... What I used is the... What is it called? The HAD badge, the Hackaday badge. So if this is the model for the Hackaday badge, then yes, this is the correct model. PKL 222 connectors, sensors, modules. So probably I need a new one. Oh, this is from the FOMO, but it looks the same. Okay, fine. Yeah, okay, well, we will see in a minute. Okay, download it. Let's see how that looks. Oh, come on. Cancel. I should copy the path from here so I can adjust it. I wish there was a file browser, a proper one, configure paths, yeah. So this is this, and then I should be able to press tab here. That would be also cool. Feature request to KiCad. Tab completion for paths in 3D model thing. So let's copy this. And the name of the file. Let's see. Ooh, that fits. Neat. That is, it does look very different than the part on that we chose, but it definitely is a good placeholder for sure. Thank you so much, Silva. That does help. Okay, let's save it. And then let's look at the board. If we can. Come on. There we go. Bam! Now we have the LED here. Very nice. Ugh, why is it scrolling? Stop scrolling. Awesome. So now we have everything. Okay, so that's that. Save this. So now we can mark this as done. And we need to, the last thing will be the MEMS oscillator. So the MEMS oscillator is from here. I think I already found it. There we go. So this is the SiTime oscillator that we currently use. And this comes in this package. But the other packages, if we look at availability numbers, let's see, quantity available. They currently have those. I think the last time I checked, they didn't even have the SiTime parts in stock on DigiKey. That's, yeah, I just was ordering more the other day, so that was a bit annoying. Let's see what I heard here. JGeo thing. Thing. I'm having trouble. Joe. Thirgo? I'm sorry, but thank you for your follow and welcome to the stream. My brain is starting to become mush already, and it's we are only 1.5 hours into the core of the stream. Vandroy, thank you for the follow. Welcome to the stream. Okay, so we will essentially try to switch it probably to this type of footprint. This is much more common. I don't feel like BGA is called for in this situation. This is actually, if you look at this picture, this is pretty cool because this is an interesting way of packaging it. This part on top is actually the silicon. And it has a cap of silicon on the bottom. So it is glued together parts of silicon. And so the mechanism of the MEMS sensor is etched on the top side of the silicon, and it's inside that cavity that is covered up with that cap, which is pretty cool. Ehens, yes, welcome to the stream, and yes, this is live. We're working on a PCB here. And welcome from Maryland. Which U number is it? U number? I'm not sure what you mean. Yes, these are, that's what I was getting to. These are the parts that were that were failing due to helium. So you might have heard a story not so long ago at a, I think it was a hospital, and in that hospital, a lot of iPhones started they broke, they just died, and people were weirded out, like what happened. So the best assumption was that they had helium tanks that they were using for the tomograph, and they vented some of that helium, and that got into the atmosphere, and the helium atoms were getting into those packages inside and changing the frequency inside those packages and changing the clock on those iPhones, and that's why they were stopping working, which is just marvelous. And one of the common YouTubers, I'm not sure which one, I'm sure someone will say that in the chat very soon, which one that was, made actually experiments where he blew helium onto these parts to prove that this is helium atmosphere does affect these parts and their frequency, which is pretty cool. Which U number on the board? So you mean on the, this is the part. Come on, if I can, oh, the auto selector is really annoying. Okay, so this is X1 on the iCEBreaker PCB. That's the X1 that we will be replacing. And this is this part, the 12 megahertz oscillator. Okay, I need to take a very short break, and I will be back in a few minutes. So be right back. Now I'm back. The audio was muted on the microphone. Let me get a sip here. There we go. So what did I miss? Oh, Ben Krasnow, of course. Ben Krasnow did that on his YouTube regarding the MEMS oscillators and helium. Yeah, so we will be replacing this part with something a little bit more common. So let's see. Oh, come on. But yeah, we will not be using the BGA WCLSP, so wafer level chip scale package. That's the rage of today, where you essentially have, oh, I have an example for you. I can show you a WCLSP package somewhere. I used to have that. No, I don't think I have it in reach. But yeah, it's the autopilot I designed. The Lisa S uses a WCLSP package on there. Yeah, Orange Crab has a bunch of chipscape packages on there. Oh, that's a good question. So what is my background? My background is computer science, but I do very little of that these days. Mostly I do electronics and hardware design, and but it vacillates. I like living on between, with one foot in hardware and one foot in software. It's fun that way. You can't use it in a hot air balloon. Well, hot air balloon you can use it, but you can't use it in a helium balloon. That must be like an atmospheric balloon or something. Yeah, I'm curious actually how this plastic packages behave, because I don't know what the permeability is of the plastic packages compared to the chip scale packages. So yeah. Anyways, going back to my background, I run 1bit², the company. We make open source hardware for open source projects. So essentially, or mostly it's me and my wife that run the company. But we design hardware that is meant to be open source, and it's meant to support open source software in general. So if we do FPGA boards, they are dedicated to the open source FPGA flow that Claire Wolf made with a bunch of other people, Dave Shah and many others. And they are dedicated for that purpose. Then the autopilots that I started with originally, the main target was the Paparazzi UAV framework, which is an open source autonomous UAV control software framework. Then we do some logic analyzers. They are also dedicated to SIGROC as an open source framework for using with logic analyzers, and so on and so forth. So everything is meant to work with and together with the open source community. And for me, it is very important to actually talk to the people in those communities, have good relationships, and know what their needs and hopes and expectations are, what kind of hardware they need, or what would improve the experience of their users. Because not every open source project wants to deal with manufacturing hardware, and not every person has the skills, time, or the will to actually assemble the hardware themselves for the use with open source projects. So this is the idea around 1bit² and what we are currently doing. So I hope that explains a little bit of the background here. Okie dokes. Yeah. So that's the footprint. I think we will be just using this one here. This is also cheaper, like seriously cheaper. 98 cents, at least on DigiKey, versus the other packagings. 95 even. Wow. That's sorted by price. Why is there... oh, enter quantity, yeah. 1K is usually apply filters a reasonable amount. Let's see what the cheapest one is. 54 cents. And this is the package. Yeah, this is the much more common package that I see. This has pads on the side. I think this is a different one. So let's see. If I take this, wrong, this one. This is the manufacturer. Let's put it in octopart and see where we can find it. DigiKey and Avnet, great, and zero stock. Wow, very much more obtainable. Not. But I think I have something really odd in here. XO, so XO is what? Oven controlled or something? So they are like temperature compensated or something? Yeah, so no, no, no. Also, we want to minimum quantity, and we want something in stock, right? In stock, apply filters. So these are value-added items. I think what is going on here, these are programmed ones. Oh, this normal kind, just crystal oscillator. Okay, thank you, Silva. So these are just crystal oscillators. Yeah, I think the point here is that SciTime has programmable crystal oscillators. And what DigiKey does here is actually program them for you and then send them out. They don't stock all the different frequencies. That might make more sense. That's why I cannot find them easily in stock on octopart. So what do we do here? Is there a different package that is even more common that we should be looking for? Because I'm not 100% convinced this is the right choice. At least there's a ton of the same. Standby in this package, even though it is all the same frequency. It's different groups, different series. There's a lot of different series. Different ppm values and different output standards. Low voltage CMOS, low voltage TTL, and low voltage or high CMOS. So these are multiple standards. So voltage controlled crystal oscillator, and what is it? DC XO? Anyways, so we just want the standard ones. Because the one that I have on the board is which series? Do I have it in here? I don't think I have it even in here. Oh, 2001. 2001 series. It's not even in here. Right. Oh no, there it is. SIT 2001B. So this is 25 to 50 ppm, 3.3 volts. And they come only in these packages. Interesting. Digitally controlled. There we go. Yeah, so they have, if I was looking in here, I could get them digitally controlled, voltage controlled, but I'm not interested in any of this. All I'm interested in is just a 12 megahertz oscillator. The alternative would be to not stick to side time at all and just go to oscillators. And then select, not sure I even care if it is MEMS or crystal. We definitely care that it is 12 megahertz. Come on. 12.2, 11, 12 megahertz. There, I want them to be in stock. And then I also surface mount, yes, please. Oh, the voltage of the I/O, supply voltage. I want something that fits in the 3.3 volt range. This looks good. Three point three, 3.3, 3.3, 3.3. There we go. Kyocera. Yeah, we could use Kyocera or Abracon. Abracon is a good, I used Abracons in other designs and I like those. And they are pretty available, Abracon. I think Kyocera too. Let's see how the pricing breaks down. Let's say just 100. Yeah, the pricing on DigiKey usually is, the difference in pricing is fairly comparable to each other. I mean, if it is cheap on DigiKey, it will be also cheap on another platform or from another vendor. That's the feeling I'm getting in general, but it's not 100%. There is some variation, so it is a little bit of a gamble. Drew is asking if the iCE40 footprint is something I made. Yeah, I think I created this one. The problem with the footprint on this board especially is that if you use the recommended footprint, there is no space for vias between the pads and the exposed pad. So I had to shrink this exposed pad a little bit to make space for the vias so that I can route it out in the space that I have available. Right, so let's look. ECS, DCS. Oh, so you use the DSC600-3. So one of these fellas here. Cool. Yeah, maybe we should just go with the microchip tech part. Does look reasonable. 64 cents a piece at 100 pieces. Yeah, oscillators are expensive. Yeah, the alternative would be, is it an alternative? I don't think it is actually. Could we use a crystal? Schneider, thank you for being here. Good question. Is it big enough to cover it? I don't remember. So this is, I think it might be just the right size. Maybe, no, I feel that it might be actually smaller than the exposed pad, but I'm not 100% sure. But I had good results with soldering it down. So it is a little bit of a compromise, and I'm sure it might cause issues. But yeah, I think it is smaller, but I'm not 100% sure. I would have to look now. I can tell you later, I guess. But I have the feeling that it is smaller than the... Right, so you need an external inverter and free I/O pin. So yeah, this is making it too complicated. I think I will just stay with an oscillator as it is. Might not be good to rely on the solder mask to isolate the VS. I know. It is a risky thing to do. The problem is I genuinely run out of space here. I might need to go to a smaller vias, maybe here, to a smaller standard than I could. But yeah, I'm already staggering this stuff back and forth to have enough space. And I don't think this is doable to route this out in a reasonable manner with the full-size footprint. Yeah. That's Z. Let's do 1. No, yeah, I know. I understand the concern, but I think I still have to stick with the risk that I will get shorts there, and just hope for the best that the solder mask will be good enough. Yeah. Oh, actually, here you go. This is where the exposed pad ends. So yeah, the exposed pad is definitely bigger than the the solder area. So we need to hope for the best. And to be fair, the chip does slightly float on the solder, so it is not. It depends on how much solder you put on there. So the balance of the solder amount on the exposed pad is really critical. How much it sucks down the chip against the board. And yeah, at the end, we are at the mercy of the PCB manufacturer doing a good job on the solder stop and actually protecting the vias. So yeah, it is what it is. What is the size of the pad on the board? This is the pad here. So can I mark it somehow? Like this. So this is the pad where the ground is. Maybe we can just go in the 3D rendering mode and disable. Where is it? Display options is this here, 3D models. There we go. So you see, this is the copper, exposed copper, and the metal part of the exposed pad on the chip is definitely bigger than that. But these good question. Why is the thing made up of multiple squares? The reason is, oh, let me show you actually. The reason is because of solder paste. This is how the solder paste structure is. So to make it easier, to have two ways of creating the openings for the solder stencil. Either you have one big pad and then you manually draw in the footprint editor those squares by hand and add the vias, which is I think the standard way currently KiCad library generators do that. Or you make multiple small pads that are next to each other and add a shrink to it. So let me show you. In the footprint editor. So yeah, if you look here, let's see if I can show you the fpaste. Yeah, there we go. So you see this is how the paste is, and the paste is just the shrink factor minus 20% of each pad. So that's how you control the shrink of the apertures of the solder of the stencil by changing this minus 20 factor to something smaller, bigger, and then all these pads have minus 20, and then you get these openings. So the alternative, as I said, would be to make it one big pad and then draw those apertures by hand. It really depends on how you skin the cat here. Yeah, so the board is description of what the board. So the board is the iCEBreaker bitsy or the iCEBitsy. And it is meant to be a breadboard-friendly FPGA development board. So you can just plug it into a breadboard with these pins on the side. You have some additional I/O and the programming pins on the end here. But yeah, essentially it is meant for easy breadboarding of FPGA designs. Okay, so we still need to make a decision here. And I think I will go with the DSC that Sylvain also is using in his design. That's not a bad choice. From Microchip Technology. You could also look on Octopart how available that thing is. Oh yeah, much better. And there's some stock at Microchip, Mouser, and DigiKey. This is not bad. Also, question: what does LCSC offer in Oscillator land? SMD oscillators. Damn, there's a bunch. Okay, let's see. We need 12 megahertz. 12 megahertz. Apply. Side time. That's a big part, though. And let's sort by price and see what they have. Shenzhen SCTF ELEC. Yeah, this is what I meant with weird manufacturers I've never heard about before. But yeah, they have this thing, 12 megahertz. That seems like a fairly common package format in those ceramic packages with a metal lid. And yeah, they are half the price essentially. The problem is I cannot just order for prototyping quickly from DigiKey if I have to. So I'm not 100% happy about this either. Unless there's something in the same type of package. Yeah, so this is, we now spent a huge amount of time just looking at parts, and this is what the reality is. You spend so much time just pondering over parts and poring over different vendors, trying to decide what is the right thing to do. Wait a second. This is not... No, it is an oscillator. Come on. One 100 nanofarad and 15 pico on the output for the test circuit. Oh, I see. Okay. To have something to drive. 3.2 by 2.5 millimeter package. Let's see what DigiKey offers in similar package. What is the size of this? 2.5 by 2. What does it say here? Come on. Where's the package size now suddenly? Just here. So 3.2 by 2.5. So this is definitely bigger. Let's see if we can find a similar package size. What did I say? 2.5 by 3.2. 2.5, 3.2. 2.5, 3.2. Nope. Doesn't exist. Great. 2.5, 3.2, 2.5. There it is. Now I see it. There we go. $61.01. I should close a bunch of tabs, I think. Yeah, so 3.2 by 2.5 DSC. And let's look at the data sheet. DFN ALG. D and E. Come on, where's the table? That has a very weird footprint. It's more weird than this guy, for sure. Yeah. Yeah, I'm still not convinced which way to go on this. In this case, so usually I do choose parts before I do layout or PCB. In this case, we are just replacing a part that I know that I already have a part that works. It's not as available, so I need to make a revision and change a part out. So that's why we are going through all this in the first place and trying to figure out which oscillator to use. But it's it's becoming really tedious now to figure out if I want to have more options, have a bigger part, use something that I could theoretically get from LCSC or not. It should be compatible with the, oh, let's see. Yeah, it's a 50, what is it? Like a 135-cent part. And this is in a 2.5 by 2 part package. Oh, cool. Yeah, so we can keep using the DSC. So let's see. If that's the case, that's a good sign. We can stay with the smaller part, which I like. And what we need to do is replace this oscillator symbol with something else and figure out. So first of all, let's find a different oscillator symbol. How is the naming happening here? I want the datasheet first. Wait. I want to see what am I working with here. Is that the 2 by 1.6 body? This is different. Let's go back to the part that we were looking at last. This one and datasheet. That's what we want. So 1. And we were looking at the 2.5 by 2 LGA. Come on, load it. .2 by 2.5, 2.5 by 2 LGA. And what is the pinout? What does it list the pinout? Maybe we should just go to the front of this and look at the pinout. So it is output enable standby FS. What does FS stand for? VDD, ground, and out. So this is still the output enable type of thing. I had to choose the right side time part that has the output enable because it depends on the model. If you have not connected a stop output enable as a pin. So that really depends on which model you get. You have to be very careful when you choose the oscillator. Let's see if we not oscilloscope, device, it's probably in devices. If we can use a symbol from these are crystals. I don't want feed. DJIMU, thank you for following. Welcome to the stream. We should be done with the boring part search part soon, and we should be able to move on to something a little bit more exciting like layout. Hopefully in the next episode we will be actually doing layout, because I think we just used up, yeah, we did use up all the time with just stupid fixing of those requirements. Come on, give me some oscillators in here. Are there no oscillator symbols? What is the naming of capacitors? No. Crystals? No. Fuses, lamps, LEDs, microphones. Do I have to make my own symbol again? Thermistor. oscillator. It's its own category. There we go. DFA. Let's see. Do we have... This is a DSC61. Come on. This is controlled. There's no DSC. Something more generic. Let's see what we have. Multiple pin, too many pins. Enabled VCC out ground. DGO. Ah, man. Yeah, we need to use an oscillator here. So we could use a crystal, but then we need... The FPGA doesn't have a special circuitry that a microcontroller would to drive a crystal directly. If we want to use a crystal, we need an inverter and we need some additional passives. We could build our own oscillator essentially and then connect it to the pin as an input to the FPGA. But it is easier to just use an oscillator that outputs by itself and has the inverter built in and everything, and use that as a clock input into the FPGA. So that's why. GTXO. Crystal oscillator, crystal clock oscillator, DIP14 package. Jesus. HCMOS crystal oscillator, DIP14. A lot of dips. There's a lot of symbols for very specific. CXO3, TFT. TCX. What does it even stand for? Euroquartz. These are very, very specific things here. Not very generic at all. ASE, XXX, maybe. One, 3, 2. Abracon ASE 4-pin. 3.3 by 2 by 2.5. Not that it really matters because we can replace it. Yeah, sure. Why not? One, let's see if this... So pin 1 is output enable. One is enable. 4 is VDD. Yes. 2 is ground. 2 is ground. Yep, you are right. So let's use this. Let's remove this guy. Ground clock 3.3. And then we can move this. And let's do that. This is incorrect. We will rename this to the this, and we will use this name for now, because we can get those easily from DigiKey as a reference. And then maybe replace with something odd later. Come on, Come on. Oh, it's very slow. I think my RAM is really full at the moment. Or I can't, come on. I can't move the label now. Oh God, why? Whatever, it's fine. I don't care now. What's going on here? Why is it being weird? Why is it starting this? What the hell are you doing? I did change to the other tool, didn't I? Oh, this is not working anymore? I cannot place wires suddenly? What the hell is going on? KiCad, you're being disappointing today. Yeah, the small stuff is the annoying stuff. We don't want this. There we go. And we should have and we need the capacitor. Yeah, this symbol is annoying. It's a stupid symbol. I rather have this stuff on the sides instead of on top and bottom. I'm not a huge fan of that here. I might redo the symbol myself for my own needs, because now I have this stupid capacitor that is just floating around in the middle of nowhere, instead of being just attached where it belongs. Yeah, well, let's move this one. We don't need this. And then let's copy this guy and put it here. So that should be it. Now we should edit this, delete this, and now we should put a new footprint here. Let's see if there is a footprint that we can use. A wonderful, huge selection of different footprints from every manufacturer but Microchip. Can we find something that is close enough? .5 by 2. Is that what we need? I think it is. I think it's close. Because I don't feel like drawing a footprint at the moment. I want something that is a good enough placeholder for now. 3.2 by 2, 2.5 by 2, 2.5 by 2, no, 2.16. Yeah, so that's this one. And yeah, that looks right. Does it? Yeah. Yeah, let's use the Abracon footprint here. Okay. Okie dokes. I will catch up on the chat in a second. Can I move this at all? Is it possible? Nope. Ah, finally. What I wanted to do is break this if I can. No, I can't. This is just a very long name. But I can do align left. Okay. Oh, where do I put you? I put you here, let's say. All right. And now let's update the annotate, update PCB, close. And now this will go essentially here in this corner around here. We still have the rest. I will have to essentially rip up a bunch of this stuff and then clean it up. But at least we have a different crystal. I still might just poke around and figure out if which exact footprint to use if I want to change to a different part. I will definitely update you if we do make some changes during the next stream. We are now beyond the 2-hour limit that I give myself, including the early start half an hour. So we will be closing up for today, but I think we can check off changing the footprint from the to-do list, even though I still might poke around and decide to use something different. The nice part about this footprint is it definitely fits nicely in the area where I had the previous footprint in, so we don't need to use much more space or anything, so that's nice. We have essentially done all the modifications that we wanted to. The only thing that is left now, which is famous last words, is to rip up the wiring and then start wiring it up again, figure out where things go as we put this together. So let me catch up really quick with the chat. Stoy Chef, thank you for following, and Cheesy Bacon, welcome. Thank you for following and welcome to the stream. I will now, let's see. Hey Captain Morgan, welcome to this stream. Yeah, still rolling, still working, but I'm almost done. Oh, thank you, Schneider. Welcome, and yeah, nice to see you here in the chat. I will definitely do more streams about the iCEBreaker and continue the work on routing this. ASE is a very common series. Yeah, so that's why maybe I should just use the Abracon. So yeah, I think, Sylvain, you are right. I should look if I can use the Abracon part. I'm sure there are replacement parts from lower cost Chinese manufacturers for the same footprints. So that might be the way to go. This footprint looks decent. I like the size of it, so we might be actually we already have the right choice. Yeah, so yeah, Mike, that seems to what just happened, where the shortcuts completely froze, and I cannot use them, and I had to poke around with the tools, and then it unlocked itself again. So yeah. Good to know. The symbol standard is annoying for small parts. Yeah, well, it depends on which parts. Usually most parts have their connections on the sides, left and right, and that totally makes sense, and that totally works fine. For oscillators, where they put like VCC on top and ground on the bottom, especially if you have a decoupling capacitor, it's really annoying. You have to just float it to the side somewhere. I don't like that. I would prefer if it was just there so I could just attach it to the part. It makes it clearer where the decoupling capacitor goes, even though it's not a big deal. It's more of a style thing than anything. Oh, there's yeah. We can keep poking around with the oscillator, Sylvain. I'm sure we can find something good. I think the path with going with Abracon parts is not a bad one. Game Boy Link, thank you for following. Thank you. Welcome to the stream. You just caught it at the very end of today, but it's nice to see more people follow. They will get notifications when I go live again. Yeah, Cheesy Bacon, you just came at the very end of the stream, but there will be more. Don't worry. So where can you find? Drew is asking where he can find the libraries. My libraries are on GitHub, Esden-Tempski KiCad libs. So this is PKL libs, and this is where you can find them. I use them as essentially as submodules for my projects, and this is how I keep them pinned to a specific version. As soon as this way I can control when I update the library, and so KiCad does a pretty good job of keeping its own copies of used symbols and footprints inside the files. So there's not really a need for the pinning per se, but I still feel like it is nice to know which exact version the project was made with, so that when I make updates, I know what footprints change, and I can actively update the full design of the board from the library. So that's how I like doing things and keeping my libraries as a submodule. Oh, so the standard requires that you put power and ground on top and bottom of the symbol? Well, that's what they decided. It's a style thing. I don't think I feel comfortable just failing them for that. I don't like that, but that's what they decided. You have to be opinionated as a librarian. So a library has to make an opinion what style of schematic capture they are going for, and just go for it. This is what, for example, they are at the moment not opinionated enough about the generator scripts, what I was complaining about before. So they have to become more opinionated about more things the further we go down the road of standardizing things and making things easier for people to contribute to. Because if you give too many options, it's a maintenance nightmare. And if you don't make opinionated decisions, it becomes too many options, and it's really difficult to contribute. If you are just quickly want to add a few footprints to a design, it becomes difficult. So, yeah. Lake Avenue, thank you for following. Welcome to the stream. All right, so I think that would be it for today. As I said before, we did all the to-do items. We grew the amount of flywires a bit. I think we have a good plan and idea what we should do in the next stream. One thing that I might change for the RGB LED is actually use smaller footprints. Wait. Are these 0402 or 603? I think they are 0603 jumpers. I think they are. So I might change those to be 0402 jumpers for the RGB LED. It's a little bit more finicky to split, but we might want to save some space on the back here. VCC top is okay if the cap points to this side. If the cap points to the side. So yeah, if you had a... Yeah, if you could put the cap here to the side and then go with the ground here. So this would be like a dongle that hangs on the side of here. Yeah, if the 3.3 and ground were here on the side, then, in a sense, it's also bad, right? Because this part is not big enough to actually accommodate ground. So I would have ground like this here on this. So I could put the grounds on the bottom of this box and VCC on the top, and then put everything like this on the completely to the side in this section here. Yeah, I don't know. I guess I could get used to it. So this is what I'm doing if I have them to the side like this. So I have the capacitors here. This is what I used to do. I like this setup a little bit more because it doesn't have so many disjointed floating things. Especially what I hate is when people have multiple parts, like 15 different parts, and all the decoupling capacitors are collected in this like garbage bin to the side. I find that very annoying, especially when then you don't know where the parts belong to. Yeah, I think I would be more aggravated with that than doing something like this. Caps horizontally, not vertically. Yeah, so have the cap horizontal here. Yeah. All right, so let's wrap this up. So we will continue the work here, and we will continue the layout of this board in the next stream. Hopefully sometime this week. I think it probably will become Thursday again. We will see. Maybe I can squeeze one stream earlier. What I did is, yeah, if you have just one part, this one FPGA, and you have a ton of decoupling caps, I understand that you have this garbage bin. What I am talking about, though, is if you have 50 different parts, small parts, each one with a decoupling capacitor, and all the decoupling capacitors are not with the parts, but just thrown into the corner of the schematic. That's what I don't like. Just to be clear, if you have a huge part and a huge amount of decoupling capacitors, I understand that you collect them all and put them to the side of that particular huge part or multiple schematics. So yeah. Yeah, I'm glad you were here. Thank you very much for following. Yeah, support. These streams are only possible because of generous people and interested people that buy our hardware. So go on 1BitSquared and buy yourself an iCEBreaker if you don't have one yet. So that's the shameless sales pitch here. Also, CrowdSupply is a reseller, and there are some of our products on Adafruit and on Mouser. So take a look at that. Otherwise, I thank everyone who is subscribing through Twitch. That does help, as well as everyone who is supporting these streams through Patreon. The Patreon funds directly help financing the gear that I use for the streams. They would not be a thing without the Patreons that are generously supporting me to invest the time and energy and the gear that is necessary to do these streams. I hope they are useful. I hope people are able to learn something from them. I love sharing the little knowledge that I have and bringing people together so that we can share knowledge. So as you have seen in the chat, we have very smart people that correct me when I'm wrong, which is very useful, and we work together to come up with nice, interesting designs. So again, thank you for the Patreons that are subscribed at the shoutout level, which would be in this case Edward Borden, Jerzy Hacker, Jordi Parky Rodriguez, Sid Price, Kelly and Tom Keddy. So thank you very much for supporting this. Yeah, so that said, have a good one. And if you have been, thank you for watching and see you next time. Bye.